We are going to continue our graphing lessons, and today we will be graphing quadratic functions. And we're going to be using quadratics in vertex form. Okay, so we've seen standard form, we've seen factored form, and now we're in vertex form. So we know that in standard form, we were able to get a lot of really good information about our graphs. In factored form, we were also able to get some information about our graphs, and the same thing goes for vertex form. And you can probably imagine that in vertex form, something in the equation will lead us to the vertex. All right, so we can pretty much count on that. Before we start looking at the vertex form, we're going to review. So standard form is y equals ax squared plus bx plus c. And our axis of symmetry was important because it led us to the vertex. And when we were in standard form, the axis of symmetry equation was x equals negative b over 2a, right? And that also gave us our x coordinate for the vertex, right? Then we had factored form. And that was y equals a times the quantity x minus p times the quantity x minus q. And in this case, our axis of symmetry was found by taking the two intercepts, dividing by 2, and that gave us our axis of symmetry and the x coordinate of the vertex, right? Remembering that P and Q are the x-intercepts. Today, we are now going to look at vertex form. And there will be parts of the vertex form that should look semi-familiar. So hopefully you're remembering from exponential equations or exponential functions. We had x minus h, we had plus k. The only difference here is the x minus h was actually the exponent. Plus k was still the constant of the equation. So there are a lot of similarities between the exponential functions and quadratic functions. But definitely try to kind of keep them separated because remember, a quadratic has an exponent of 2. So that's why we won't have the x minus h as an exponent. However, a lot of what you knew based on the exponential function does actually apply here too. Here's what I mean. So if you remember to exponential functions, the a represented the stretch, and the a still represents the stretch in this case. So, let me make that wider. So the a is the stretch, or compression, and you might hear the word expand or shrink, right? So a stretch or compression of the graph and when a is negative, if you remember from our exponential functions and from the last lesson on factored form, the a still determines the direction that the parabola is in, or the direction of the exponential function. So when a is negative, the graph reflects. It look like this. A is positive, it's a U shape. Okay, so next up is the H. Make this bigger. So for the H, just like when we dealt with exponential functions, the H actually was the horizontal shift, and the same thing happens here. So it's the horizontal shift or translation from the parent function. Now, something to remember, and this happened with the exponential functions, and you have to be very careful, it's x minus h. So if you have x minus 2, the shift is actually positive 2. If you have x plus 5, the shift is actually negative 5. So be very, very careful. Okay, and you can even make a little note that says, if h is negative, it shifts to the left. If h is positive, we shift right. And finally, we have the k. And just like when we graphed exponential functions, the k is the vertical shift, or the vertical translation. Okay, and if k is negative, we shift down. If k is positive, shift up. Now, as for the vertex, what's very interesting is the vertex is actually in the equation. Okay, so there we go. The vertex is HK, which is really nice because they put that in alphabetical order for you. But if you think about it, H is the horizontal translation, and horizontal is left to right, which should remind you of, X axis is left to right. K is the vertical shift, and that's how the Y axis is set up. The axis of symmetry is then going to be X equals H. Remember, our axis of symmetry is a line that creates like the mirror. And so the equation for the axis of symmetry would be X equals H. The K is our minimum or maximum value. Okay, so K tells us our maximum or our minimum. It's like the range. So it'll tell us um, the range would be less than or equal to k, right? Or greater than or equal to k. All right, so we're just going to go ahead and start graphing. Get to where my coordinate plane is. So let's just jump into an example. So we're going to graph y equals -2 times the quantity x plus 3 squared plus 1. So we're going to identify all the parts first. So a is -2, h is -3, and k is 1. Now, remember, our vertex form is a times the quantity x minus h plus k. So since I have x minus h and I have x plus 3, h would have to be -3 because x minus -3 equals x plus 3. So keep that in mind as you go through this. That's why it's really important that you take a second and you identify each part. That way your brain's not trying to organize a ton of brand new information all at the same time. So our vertex is HK. And you'll notice in the notes, I'll write this basic info first before I start plugging information in. And remember, that's just to kind of start creating muscle memory and get you to remember these important pieces. Okay, because this is going to show up over and over the next few years for you. So my vertex is HK, which becomes -3, 1. So I can go plot that point, -3, 1. Now, then we need to decide, is it going to open up or is it going to open down? Okay, so A is negative, so it's going to open down. And we need to decide, is it going to stretch or shrink? So if A is -2, that's actually going to be a stretch. Now, this part is a review from the last set of notes. And if you remember, let me make a little note here. If the absolute value of A is greater than 1, it's a stretch. If absolute value of A is less than 1, it's a shrink. Right? So stretch is going to make or probably get real skinny. Shrink is going to make it really wide. Okay? So keep those things in mind. So important information right there. And now the open down and the stretch doesn't specifically tell us what the points are, but it does give us an idea if we're graphing correctly. Okay, so if I start graphing this and it looks like a very wide parabola, I know that there's a very good chance something weird happened. Or if it opens up, I know something strange happened, like maybe my math is wrong or something like that. Okay, so our last step is going to be to find more points. Okay, so this is very similar to the steps of the other examples. All right, identifying the A, H, and K. So identifying the important pieces, finding the vertex, deciding if it opens up or down, and if it stretches or compresses, then finding 2 more points. So let's do that part. So if my vertex is at -3, I want to see what happens when x is -2. So I'm going to substitute. Oops. And just work it out. This was a good number to pick because it made my math pretty simple. So when x is -2, y is -1. And remember, my axis of symmetry is the x value of my vertex, right? So that's my axis of symmetry. So then I should have a matching point at x is -4. So then, then we can see what happens when x is -1. That'll keep my numbers pretty manageable. So I get -7. So -1, -7. And then again, we have a reflection. Do your best to connect those points. And there we have our parabola. Let's look at another example. So graph y equals 1/2 times x minus 2 to the second power plus 3. All right, so let's identify our important parts here. A is 1/2, h is 2, k is 3. So let's find our vertex first. And we know the vertex is HK. So 2, 3 is going to be our vertex. It's also going to be an indication of where our axis of symmetry is, our mirror type line. So now we need to know, does our graph open up or open down? Now 1/2 is positive, so it's going to open up. Right, so A is positive, so it opens up. And then we need to decide, is it going to be wide or skinny? Is it going to shrink or stretch? Now remember, when we think stretch, a lot of times we feel like that's a widening. Remember, this is vertical, right? So if you imagine like a picture, okay, so I'm going to take this graph here, okay, or actually even better, let me draw, I don't know, picture of an apple. Okay, so here's my beautiful apple. Now, if I take this picture of the apple and I'm only doing vertical stretches, if I take my apple and I stretch it up, it gets taller, right? If I take my apple and I stretch it down, it actually becomes short and wide, right? So a vertical stretch down actually is a shrink. I'm shrinking it down and it looks shorter and wider. If I pull it up, that's a stretch and it gets taller and thinner. Okay, so hopefully that kind of helps that make sense. Our first reaction is when we hear stretch, we think wide. Okay, so just kind of keep that in mind. All right, so the absolute value of A, the absolute value of A is less than 1. So that means it's going to be a shrink. Okay, it's going to get wider like this, as opposed to on our other graph, it was a stretch and it had that taller shape. All right. So again, those two details are just going to help us self-check as we go on to, step 4, and we get a couple extra points. So let's do x is 1. So 1/2 times 1 minus 2 to the second power plus 3. Now I can already tell that I'm going to end up with a fraction. So at this point, I can continue on with the fraction or I can bail out, which I'm going to do just because my graph is not big enough to try to get an accurate picture. So I'm just going to bail on that option and I'm going to go x is 2. And that's actually going to make my math pretty simple on this. 2 minus 2 is 0. So y is 3. So x, oh no, I already did. That was silly. Sorry about that. We already did that one. So I guess we just checked ourselves and realized that we are correct. I'm sorry about that, you guys. So let's go with x is 0. I know that's going to get me an even number to multiply by 1/2. -2 squared is 4. So please be careful and make sure that you're paying attention to those negative signs. So I get 5. So when x is 0, y is 5. And because of my mirror, that's what we'll get for those points. So I'm going to continue with this, trying to pick even numbers. So if I go to 6, now what's going to happen here is if I do choose 6, we're going to end up with a situation where I'm off my paper. So let's see what we have here. So 4 squared is 16. 16 times 1/2 is 8. So I'm barely off my paper. I could probably go with this. So when x is 6, y is 11. So somewhere right about there. So that means that when I reflect, so this isn't too bad. Okay. At this point, if we would have went way off the paper, then we probably would have wanted to go back and do 3, even if we got fractions or decimals. But this actually worked out. So make sure when you're working on these, we see these points. Okay, it's going to be important. All right, last situation you're going to see, or that we want you to be prepared for. And on a side note, remember, if you can't remember all those details about what makes the vertex, opens up, opens down, if you can't remember all that, know that you can always make a table. So make a little note to yourself. You can always make a table. Okay, that's as long as you know that the x's and the y's together make ordered pairs, whether you're drawing a line or a curve or any type of shape, knowing that if you pick an X and plug it in, do the math and get a Y, that's an ordered pair. You do that 4 or 5 times, you have a basic idea of what the graph would look like. For example, whether it's going to be a line or a parabola. So you have a general idea. You can graph anything. Okay, you know you're in high school, you're taking the SATs, ACT, you forget how to graph something, make a table. Okay, it will save you over and over. So again, if you forget these details, make a table. All right, example 3. Now we're going to go backwards. So write an equation to represent the function. Okay, so now we're going to give you the information and you're going to give me the equation. Okay, so reflected over the x-axis. Okay, so reflected over the x-axis. Then translated 6 units left. And that's it. It doesn't translate up or down. Okay, so now it says it's reflected, but we're not told if it stretches or shrinks. So if the parabola does not stretch or shrink, that means the A has to be 1. Okay, because if the A is 1, that means it's like a scale factor of 1, so the size doesn't change. But if it's reflected, that means we have a negative. So A has to equal -1. Now, if it's translated 6 units left, that means that my H has to be negative, right? If you look up at your notes, you'll see that if H is negative, it translates to the left. So H equals -6. Now there's no information about translating up or down, so that means it must not translate up or down. So that means K equals 0. Okay. So now all we have to do is take our general format and substitute our information. So I get y equals -1 times x minus my h squared plus my k. Now you might be able to kind of organize that in your head and deal with the minus negative situation. But in case you can get distracted like I can, or you just want to make sure that you're taking your time, I would just leave it x minus -6 at first at least. So I technically don't need a -1, I just need a negative sign. X minus -6 is really x plus 6. And adding 0 on the end is not necessary. So there's my answer. Ooh, sorry about that. Let's look at one more. So that's example 4. All right, so here's our information. Stretches by a scale factor of 2 translates 3 units right and 4 units down. Now remember, this information is based on the parent function, right? So if you took the parent function, you would take that parent function and you would stretch it by a scale factor of 2, and then you would translate it as we're given information here. Okay, so we know if it stretches, that means that the absolute value of a is bigger than 1, and it's 2. So that tells me that a equals 2. Translates 3 units right means that h equals 3. 4 units down means that k equals 4, negative 4. So when I substitute all of the important pieces, I get y equals 2 times the quantity, x minus h squared plus k. Now everything is nice and simplified except the plus negative 4 at the end. We do want to clean that up a little bit and just say minus 4. And that's it.